Hello, in this video I'm going to be solving exercise 6.3.8 from Jiří Lebel's notes on Diffy Qs. So in this exercise we're given this inverse Laplace transform right here, and we are told that we need to compute it using convolution. Okay, well, how is this going to work? Well, here we need to remember how the Laplace transform works or acts on convolutions. So act on a convolution f star g. Here, the key result that we're going to use is that if you take the Laplace transform of the convolution of two functions, it is exactly the same as taking the product of the respective Laplace transforms. So, in general, when we multiply two functions, just like f times g, where here I'm using the single dot instead of the star, this is not the same as L of f times L of g. We can fix this, though, by using f star of g instead, where star is the convolution. And as a reminder, f star g is a new function, and this new function is given by this integral here. So we integrate from 0 to t, and the integral is of f of tau g of t minus tau d tau. So this is the convolution of f and g, at least for our notes purposes. How is this going to help us? Well, you might notice that the expression we have inside this inverse Laplace transform, which is s over s squared plus 4 squared, we can rewrite this as s over s squared plus 4 plus 1 over s squared plus 4. No, not plus, sorry, times. And this in turn is exactly the Laplace transform of, well, the inverse Laplace transform of this, because 4 is 2 squared, is going to be cosine of 2t. And likewise, well, here we need to multiply and divide by 2, but here we get the Laplace transform of 1/2 sine of 2t. Why is this useful? Well, we know from the above that this is equal to the Laplace transform of the convolution of these two functions. Cosine 2t convolved with 1/2 sine of 2t. Therefore, it follows, by taking the inverse Laplace transform, that L inverse of s over s squared plus 4 times 1 over s squared plus 4. Well, when we take the inverse Laplace, it cancels out with here, and we're just left with the convolution of cosine of 2t and 1/2 sine of 2t. Okay. Now, let's go ahead and take this a step further and compute the convolution of these two functions right here. So, okay, this once again. So here we need to be a bit careful. Maybe here it's better to use a different variable for our function. So I'm going to let this input variable of mine be u. So the convolution of our two functions is the integral from 0 to u cosine of 2 tau times, or not times, it's cosine of 2 tau, and then we're doing 1/2 sine of 2 of u minus tau. And so, what does this give us? Well, all that we need to do is figure out what this integral is. This might look a bit messy, but everything will turn out okay because, well, we just need to expand this right here. 2 tau. So let me go ahead and factor out the 1/2. So we get cosine 2 tau and then sine of 2u minus 2 tau d tau. And then using a trig identity, the sum formula for sine, well, this is sine x cosine y plus cosine x sine y. What this gives me is that this is equal to 1/2 integral 0 to u cosine of 2 tau. And then we're going to have a sine of 2u cosine of negative 2 tau plus cosine of 2u sine of negative 2 tau, all with respect to tau. And so, just copying this over to the next page. What do we get? Well, this in turn is going to be equal to 1/2 integral 0 to u, and then we're going to distribute the cosine inside. Cosine 2 tau, sine of 2u. Note that cosine is even, so cosine of negative 2 tau is the same as cosine of 2 tau. And then here we get plus cosine of 2 tau, cosine of 2u. But sine is odd, so sine of negative 2 tau is the same as negative sine of 2 tau, so this becomes a minus. And now, okay, the u's here are all constants with respect to tau, so if I distribute this integral, I can factor out sine of 2u from the first integral. And here we have 2 copies of cosine 2 tau, so this is cosine squared. And for the second integral, we can factor out the cosine 2u. And we get 0 to u cosine 2 tau sine of 2 tau d tau. And so now all that remains, and oops, actually I forgot that this factor of 1/2 goes to the other integral too. So this will be minus 1/2. Okay. So now all that remains is to evaluate these 2 integrals here. This one in blue and this one in purple. The one in purple is a bit easier. You might notice that this one's actually amenable to a substitution. So if I let v, because I'm already using u as my input variable, if I let v equal sine of 2 tau, then dv is 2 cosine of 2 tau d tau. And so my integral becomes, well, plugging in the bounds, sine of 2 times 0, sine of 2 times u, and then I need to solve for cosine of 2 tau d tau by dividing by 1/2, so I get 1/2, and then this is all v dv. But okay, this is 1/2 sine of 2 times 0 is 0, and then we get sine of 2u up above, v dv. And this is easy enough. This will just be 1/2 times sine squared 2u over 2. So here I'm using that an antiderivative of v is v squared over 2, and then I'm just plugging in the bounds. And altogether, what we get is sine squared of 2u over 4. What about the other integral? So we have integral 0 to u cosine squared of 2 tau d tau. For this one, we need to use another trig identity, and the one I'm going to use says that cosine squared x is 1 plus cosine 2x all over 2. And what this gives me is that this integral becomes integral 0 to u 1 plus cosine. So here it's for x, but I have 2 tau inside of my cosine squared, so this here is going to be 4 tau now, all over 2. So this will be 1/2 integral 0 to u 1 plus cosine of 4 tau d tau. And when we integrate, this is going to be 1/2 tau minus sine of, sine of 4 tau divided by 4 because of the factor of 4. This goes from 0 to u. And so when we plug in the lower bound 0 into both of these terms, it just gets 0. So this is ultimately 1/2 u minus sine of 4u over 4. And let me make my 4's look a bit more like 4's. There we go. Altogether, if we put together the blue and the purple integral, we end up getting, from the lines above, 1/2 sine of 2u times 1/2. So if I do 1/2 times 1/2, it's going to be 1/4. So let me go ahead and clean it up now. So this will be 1/4 sine of 2u, and then u minus sine of 4u all over 4. And for my other integral, I get minus 1/2 cosine of 2u, but I'm dividing by 4, so that's going to be minus 1/8 cosine of 2u, and then I am multiplying by sine squared of 2u. And this right here would be our final answer for the convolution of the two integrals. Okay, that's it for this video. If there are any questions, please feel free to leave a comment. Otherwise, I will see you all in the next video. Hello, small correction. So I accidentally, when integrating cosine of 4 tau, I added this minus when it's supposed to be a plus, because when we integrate cosine, we just get positive sign. So this is actually supposed to be plus plus right here. The only thing that changes for the solution is that this minus right here will become a plus. And so just making my u look a bit better, we're going to get u plus this. Sorry about the mistake, but yeah. This is supposed to be a plus right here, not a minus.